Okay, cool. Well, I wanted to thank Judy for giving me this opportunity to speak at this event. It's been a little while since I did have done any speaking events, but I used to do it earlier in my career, and I was a teacher, so I'm sure I'll figure it out. I am in the Baltimore area with the Maryland DevOps shirt that I picked up from the last Baltimore DevOps days, and I'll be down at the one in DC in the fall. I think it's September. The idea with this talk was one, I had a 6 week career break after I quit my last job. I've started a new job recently, and I was like, hey, what can I do to keep learning? And as some of you know, a year ago is when ChatGPT 4 came out and LLMs really started. I remember seeing in late 2023 on Twitter when I was still on Twitter, seeing all this ChatGPT stuff, and everybody was starting to talk about chatbots. It was really daunting to try to figure out where you should start, particularly if you're an infrastructure person where you worry about servers, you worry about uptime and monitoring and Terraform and pipelines. So like, how can you even fit in when everybody's thinking about writing chatbots and LangChain and Python and agents and all this? So this talk really focuses on, what the first part is what are the potential roles for those of us that are on the infrastructure side, DevOps, SRE, platform engineering, whatever you want to call it, in this new world of large language model and applications driven by LLMs that have vector databases and use retrieval augmented generation and all these buzzwords that we're hearing about. What is a potential role for us and how do we stay relevant? Because I've been yeah, so that's the first part, and then I'll kind of talk it. The second part is much more about the tools that I've learned and both running locally on my laptop as well as in AWS and GCP to kind of teach myself model hosting, learn about the different, models and ways of, statistics around inferences and all this stuff, that I'm trying to learn like everybody else, because everybody is learning this from scratch. So a little bit about myself. I've been in tech for about 26 years. I got out of when I graduated from college down in Texas A&M. I was actually a teacher. I taught reading and history for about 3.5 years, but I was also in the military as a signals intelligence analyst. Some of you in the Maryland area know about what that means. But I ended up getting into cybersecurity, working for a defense contractor, and then went on to work at Cisco, doing a lot of product security, pen testing, vulnerability research, and then late 2000s, 2008, 2009, I started hearing about this thing called DevOps, and I was working at SAIC in Columbia, and then I had an opportunity to work at ZeniMax Online to work on the Elder Scrolls launch, and this was pre-announcement. So up in Hunt Valley here, we initially did we had a private data center where all the devs, game devs did their development, and then we launched the website in AWS, and that was my first kind of production use of AWS with Chef Solo and manual, Python Boto infrastructure. This is all before Terraform and all of that. And then I went on to work at a number of primarily cybersecurity companies running infrastructure teams, Mandiant down in Northern Virginia, FishMe also in Northern Virginia. And then right as the pandemic, but right before the pandemic, I worked at T. Rowe Price over in Owings Mills, and then went to Ping Identity where I just left. And then now I've joined a new small consulting firm, startup based in Toronto, as the first US employee called Deep Cove Cybersecurity. So you can check them out. Anyway, other things about me, I took this really cool trip to Europe in the fall. This is a picture in Bastogne, Belgium. I like history. So this is downtown Bastogne. So I will get started. So what are we trying to do here? So first of all, the idea, there's a couple of different definitions of like AI ops, and AI ops and has been around for a while, since maybe 2019, 2020. And in one of that GitHub reference that you posted, like the AI cheat that I posted, an AI cheat sheet, there's a whole bunch of presentations going back to 2019, 2020. There's kind of two different definitions that I've heard of both like AI ops and LLM ops. There's the using AI to do operations, and then there's the what it takes to actually build and run and deploy large LLM applications or AI-based products. So what I'm talking about is the later here. So we're not going to be talking about how to use LLMs to generate Terraform, Ansible, or any of that stuff. We're not going to get into the hardcore details of fine tuning or retrieval augmented generation, and we're not going to talk anything about prompt engineering because there's a lot out there on that. This is more thinking about if you're in an infrastructure engineer, operations engineer, DevOps engineer, whatever you call it, how is the space of LLM applications relevant to you, and how can you possibly fit in? So interestingly enough, when I was hunting for a job Q4 and Q1, I just started to see these really weird AI SRE positions start to pop up. And I was like, okay, what's going on here? Where you basically needed all this operations experience, incident management, performance, and then also ML tools and all these standard Python frameworks. You need to be an SRE and a machine language, engineer, and that's pretty hard for people to do both, because typically people that are good at data science really don't like running infrastructure and being on call. But I started to see these weird jobs pop up. And then this was another one. There was like DevOps and that required knowledge of compliance and GDPR and all this. So maybe there was something to that. So that was giving me an idea, like, okay, maybe this is a thing that we need to start thinking about. But since I've been doing tech a while, I've been through kind of multiple generations, and around 2011, 2012, there was this whole no ops movement when tools like those of you that were around at that time, tools like RightScale, where, oh, well, we don't really need operations anymore. Developers can do everything. Well, guess what? We still need ops folks. And the same thing happened with serverless. I went to the first serverless conference in 2016, took the train up to Brooklyn, and Charity Majors is, one of the best bloggers out there, both on leadership and also kind of infrastructure. And she gave this really cool presentation about, like, yeah, even if you're getting rid of the servers, all of these things about the illities, the non-functional requirements, security, resiliency, all these things, operations is still a thing regardless of the technology. And despite every single wave of technology, when we move from physical VMs to the cloud, when we move from VMs to Docker to Kubernetes or whatever, there's still a need for ops folks. So I think that's good news. So I was sort of curious, and we'll get into some examples of hosting models locally. Like, okay, which models even know anything about this made up term LLMOps? And this was Mistral, and this was running on my local map. Community, right? DevOps is all about community. Deployment of models, infrastructure, develop self-service, tooling, observability. The M in Calm for metrics and the definition of DevOps, efficiency, scaling deployments. Okay, and this was a 7 billion parameter model running on Olama, and it gave a useful answer. And then I decided to Command R is another new model, and I'll get into kind of where you can see what are the latest models that are out there that you can run on GPU machines or run on if you have a GPU on your laptop. It actually even gave a really good definition, and I wrote this. I just did this a couple of days ago as I was preparing for this, and infrastructure management, model monitoring, scalability, cost, governance, IR, incident. I mean, I've been doing security, and many of you have been also doing, traditional, operations. All of these things are going to be needed once LLMs become widely deployed. So I think that's good news for us, because this is, what we do and what we have done. And this is, I don't think this is a hallucination here. This is legit. So, if I think about when I ran SRE teams, or, these are the things that we care about that are typically under the waterline, that sometimes product management doesn't care about, because all they care about the business logic and the features above the waterline. But how things are versioned, how we manage configuration, secrets, environments, pipelines, promotions, rolling back, rolling forward, observability, how we govern the tech. All of this is going to apply to when you start testing models, deploying models, using back end, infrastructure that hosts models. And there's no getting away with this. So that's good news. And part of this is if you think about there's many of the presentations and books on generative AI, large language models, say that it's a progression from artificial intelligence, which is 30 to 40 years old, machine learning 15 to 20 years old, deep learning 10 to 15, 5 to 10 years old, and then generative AI 3 to 5 years old. And I think from a operations perspective, it's the same thing where data engineering, how do you manage data across multiple environments, tools like dbt that are used to kind of have the same sort of infrastructure as code for tables and schemas and data sets and things like that. Airflow, Dagster, all of that, the data orchestration and cron job, basically cron jobs and ETL pipelines. All of that stuff is, required because data cleansing, data purity, data monitoring, provenance, all of that comes into play even more once you get into, data sets that are used for, training and tuning. And in the same way, this is building upon, previous generations of, best practices around, technology operations and engineering. And the same thing, you're going to get into, one of the interesting things I've learned is if you're depending on with tools like Ollama, whether you're running a prompt, if it's doesn't have a GPU, if you're running a GPU with different size memory, different hardware GPUs like A100, kind of a high end or a low end, T4 GPU, you'll get different answers. So this whole idea of testing and reproducibility, because in the way that output is generated from prompts, it is non-deterministic, it is probabilistic. And that means testing and monitoring is even more important because it's not like in a standard application where you do a health check and there's a 200 or you have a range of metrics that are coming back. It is literally changing based on each prompt. So the sorts of kind of operational concerns around, about what does working even mean, are even more important and more challenging. And interestingly enough, I started I really started getting interested in this whole idea of continuous delivery and what DevOps meant and, and deployment for machine learning right in, early 2020. So the last conference I went to before COVID broke was in January in Seattle. The other kind of interesting thing is I was like an hour from a mass shooting as I was leaving, and I got this text a few hours later from T. Rowe Price asking if I was okay. So that's like the memory of my last conference. But this was there was only one of these delivery conferences that happened, and all the big shots in continuous delivery were there. But there were two really interesting presentations that talked about the challenges of just deployment of straight machine learning and packaging up the code, productionalizing the code from data scientists, and how they there are challenges of operationalizing that, Jupyter notebooks. So even in 2020, before this whole kind of generative AI wave, I started getting interested in tracking this stuff. So let's pause for some questions and see if there's anything. If not, we'll keep going. We're at about 20 after. That's an interesting idea. I have not. I guess treating course content as pipelines, I guess, is that everything could be a pipeline? Is that kind of the idea? Is that Abu? Is continuous training a thing? Anybody know? But no, I haven't heard of that term. But everything can be a pipeline, right? Go ahead.
Oh, I was gonna say, I heard of something very similar, but not, formally named continuous training. As I understood it, continuous training is where you are taking the prompts and responses, and taking that back into your LLM model for training.
Ah, that makes sense. Yeah, yeah, yeah. I've heard of that. I haven't, like I said, I'm just kind of learning this. I'm not an expert in machine learning. In my new company, we definitely have some LLM projects where we're working on security tooling, and I'm, starting to get into this space. But right now, uh, I haven't been involved in any production. This is more about what I've learned. So, but yeah, this idea that pipeline, like if you look at, AWS tools such as SageMaker, Azure DevOps, all of them have, all of these, yeah, ETL, data preparation. Yeah. Yep, 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 yep. There's a lot of this is built into kind of like the SageMaker suite of products at AWS. Yeah. Cool. Any other questions? Or we'll move on. Okay. So second part of this is really to kind of talk through the things the tools that I've used and what I've learned, uh, more from like the infrastructure up standpoint. And if you have not had a chance, if you're not a machine learning expert or not an AI expert, some ways where you can start kind of building out your knowledge the way I have. So first of all, I'll kind of switch over to a mind map that I wrote. Has this switched over? Last year, about a year ago, as I was, starting to kind of figure out who were all the vendors in the space, because there's just so many startups, most of the VC money has gone to AI, learning about the technologies, embedding what that means in terms, what's the difference between transformers, GPT, generator versus, transformer models, tokenization, what are classifier, and then a lot of this is all based on like semantic search and NLP. So that's where Cohere, has some really good, I mean, really good documentation and training materials. So there's a lot out there, and data labeling, and then this is more the kind of ML aspects. And then there was this whole realm of kind of vectors, basically storing these matrices that are generated of the prompt to do, you know, and folks that are real mathematicians, I'm just making this up, can do a better job explaining this. But these are the fundamental kind of technologies that a year ago I was trying to figure out. Okay, what do I need to learn? And then there's obviously all the Python frameworks, uh, and LangChain was the biggest one that I first started hearing about, and I joined the LangChain uh, Discord server, and it was just kind of overwhelming because there were so many people publishing apps, uh, and then I sort of paused until later, earlier this year, when I kind of started working on this idea of LLMOps. Is like, instead of thinking about trying to understand and learn all the models, the difference between the models, GPT-3, GPT-4, and how many parameters they are, and all of that. Think more about the best way was to kind of learn how to run it and how to self-host it. But a year ago, really, even over the summer, there were not really effective ways of running models on even in AWS, on EC2 instances, uh, or on your local laptops. But that all changed, and I'll get back to the presentation here in late 2023, with the number of tools that came out. So I'll get back to that now. So one point here, yeah, I can. It's in my GitHub page. I'll share it. This is old. I was trying to find the source of it. So one of the things that I think, and I've listened to a ton of podcasts, and there's so many of them. Some are good, some of them are garbage. But one of the things that I've been watching this for about a year is I think that there's not going to be one OpenAI, one provider. It's not going to just be OpenAI. So there will be multiple models, open source. When Llama was released last year, and Llama 3 just was released by Meta today. I just signed up on Hugging Face, but it's already available on Ollama. And I'll show you this. One of the interesting things is that if you go onto Hugging Face is basically kind of like the GitHub for models, and you'll see that like when Google released their open source model Gemma, you have to sign up and accept a EULA and all this stuff. But with Ollama, you can just pull it down like a Docker pull, and that's one of the really cool things about Ollama is it takes the abstractions that we're used to with Docker in terms of pulling images and layers, and it allows you to do the same thing with models. But anyway, to me, this is why I think that there's a place for running models, knowing how to run models, monitor models, deploy models. It all isn't going to go to the big players. And one of the big reasons, and maybe I'm kind of biased because I'm in the security space, is that there are serious concerns about compromise of data. I've been on incidents where employees send data to ChatGPT, and unlike a normal breach, you just don't know. You don't know what's going to happen, if it'll get trained, if it'll get spit back, if it'll be added. It is this non-deterministic world where you just don't know what's going to happen. And then also the reality is, and most of us are in either Azure, Microsoft, or GCP shops, we want to have, or organizations want to have that data within the safety of their existing vendors, where you are, what the isolation is, about the privacy controls that are available from that cloud provider, the data segmentation and all that, where if you're using OpenAI, if you're using, Anthropic with Claude, you just don't know. So I think there's going to be a place for organizations hosting models and running models and model-based applications in their clouds, and it's not all going to go to ChatGPT and OpenAI. And then the other piece here that multiple people that are running these in production and building products is that the models are getting smaller and smaller towards where they're going to be running on a phone, they're going to be running on an IoT device. So they're going to be more embedded down in, closer to the compute, and it's not all going to be a cloud service. So this all means that this is just going to be another piece of, when we're involved with testing applications and running applications and deploying, there's going to be a need for LLMOps engineers. So one of the big challenges, yes, vector databases. I've been using Qdrant with private GPT. That's private GPT is a nice way to kind of index applications and run questions. But there's, and I have a slide here on some of these vector databases down here. Postgres has also added vector support, so there's a lot of debate as to whether or not vector databases are really needed if databases like Elasticsearch and Postgres already have the ability to do all that vector math. Are these vector databases just kind of a AI VC bubble? But time will tell. But back to the point here. LangChain is probably the most popular framework for building applications because it handles all the prompt, a lot of the prompt chaining, the data management, and it provides an interface to so many of the different kind of hosting platforms, whether they're running them yourselves or in the AWS. So when you're looking at tools, because there's so many tools in GitHub, and just like with any other tool, other system, other categories of apps in GitHub, some of them are not well maintained, and this space is moving so fast. So kind of a cheat code is, if you find a new tool in LLMs, is it supported by LangChain? So like Ollama, which I'm going to be talking about, Llama CPP, which was a really big deal that allowed all these open source model formats to be run locally on general purpose hardware or use a GPT. These are all supported, and then all of the big players. So even if you're not writing applications in Python for LLMs, tracking some of the frameworks to just know what's the most mature tools that are available. LangChain is a great place for that. So if you think about what are the kind of narrowing down, what are the big players and what do you need to know about to really figure this out? For everybody knows NVIDIA, understanding about CUDA, anybody that's been involved in like high performance computing and clusters like Slurm, Slurm are these ways of basically running jobs across multiple CPUs, multiple nodes, sort of like, if anybody remembers Beowulf clusters and, all that high performance computing stuff, and folks that are in cool ChatRX, I haven't heard of that. But obviously understanding about CUDA, understanding about GPUs, how to install those libraries, on Linux, understanding the different hardware interfaces, kernel modules, all that Linux stuff is useful because NVIDIA is good at Streamlit is a great web pack, for easily packaging up frameworks. DK, good call. So anyway, NVIDIA is pretty much at the core of this. They just had their developer conference. It was I watched some of it. It was pretty crazy. But the big cloud players, everybody has is in this space. Then there's the niche players, Cohere, Canadian company, Anthropic, OpenAI, and then there's a bunch of different Elasticsearch, Postgres, and then Pinecone, Milvus. They're both SaaS and self-hosted versions of most of these are if it's a fairly simple vector database, it can run on a just under Docker Compose, but most of these also distribute Helm charts, so it can run on Kubernetes if you don't want to use their SaaS offering. And then, like I said, Hugging Face is that's the main place for pulling down models. And then there's just a variety of open source models, Llama models, Microsoft. People sort of make fun of Microsoft's model because it's not very good, or so people say. And then Mistral was a big deal that came out of French company that is actually kind of one of the best models that I've seen for a lot of the kind of question and answer use cases. I really haven't done much with CodeGen, using any of those kind of Python or Linux. I generally use ChatGPT if I'm doing that. So the hardware that I've been using to kind of host OpenLLM to run Ollama is, I have an older MacBook with only 16 gigs of RAM. It's an M1 Air, and that will run some of the smaller models and get responses back in a few seconds. It works, and that's I'll show some prompts there. And then I got a brand new work MacBook Pro that is really nice, M3 Pro 11 core, that also does an even better job. But generally what I've been doing is I'll run Ollama because it's just a web service on my Mac, so I can take advantage of the GPU, and then I'll run multipass for my Linux VMs on my Mac. And then that's where I'll package up and run, install the Python applications, and then connect back to the host on that, so I don't have to kind of pollute my Mac with all sorts of kind of crazy Python libraries. So that's the model I've been using for running locally. And then in AWS and GCP, you can get, if you're doing spot instances on GCP, you can get NVIDIA T4 with around 15, 16 gigs of RAM is about the minimum that I want to use when I'm running Ollama. It's around anywhere from 15 to 25 cents an hour if you're doing spot instances. And I obviously don't leave them running. I just fire them up, and then AWS is more expensive, but on the G5, G6 series, it works just fine. And I'll kind of show you how that install works. These are if you think about the tools, if you haven't done this before, understanding Llama CPP, the models that it supports, that's because Ollama is built on that. And this is another way, if you look and see, this? So Llama CPP is basically, it's another place if you're looking at what are the supported models and how to run them locally. And it's very simple as just to running a make file and starting to chat with it. And then you'll see all the different parameters. And Ollama, you'll see the same because Ollama is using Ollama's in Go, but it's using Llama CPP. You'll see all of these in the syslog when you fire up and load the models. And then what I've been doing is I'll compare two different models to look at the different parameters, because the way I tend to learn is by doing things, running things, and Llama is an important tool as you start to try to figure things out. And then to kind of get into Ollama is this really easy. This is just running on my local map. So if you do, so it's just like Docker. So let's see if I can find and it's just like Docker Hub as well. You'll see that the Llama 3 just came out today by Facebook, and I've read about them. I've seen them. I'm not I can do a little bit with Python. I don't do a lot of coding in Python all the time. So I've been focusing more on just how to run them. But it's to basically use these models. All you do is, yep. So I'm running on both GCP and Google Cloud. So GCP and AWS. So just like on Docker, and I'll switch back to the slides here and see if this loads up here. You just run a pull, and it will start pulling down the layers, just like on Docker. And it seems very similar here. And this is the kind of latest. They're updated very fast, and you can search for all different types of models here for code generation and specially tuned ones, and even SQL generation like DuckDB. If you've used any of those kind of tools, there are specific models for generating SQL. So Ollama is really cool. Let me get back to my slides here. So Hugging Face, if that's one place that really you get an account, and you'll see these leaderboards where as new models are developed, and then you'll see there's these different formats: GGF, GGUF, GGML, and then formats called like safe tensors, because a lot of these models are stored as Python pickles. And since I do most of my work in security, pickles are subject to kind of data serialization and those sorts of attacks to allow arbitrary code explanation. So there's a whole new, Hugging Face developed a new model format called safe tensors, which had extensive security review from Trail of Bits, which is a high-end security company. So Hugging Face is definitely something you need to learn. And then what I also did next was, once I had it set up, learning the APIs, and there are SDKs for all of these, to just start sending prompts and iterating through all my different models, a simple for loop. Because one of the most interesting things is running prompts against different models with different temperatures, and all these the different kind of inference settings to see how they compare. And then looking at the results, because if you want to like test, factual question answers, and then you could basically run them again, capture the results, and then you could use a higher performance model like, ChatGPT 4 to kind of analyze all your responses. So learning Python, being able to query the interfaces, it's a lot of JSON parsing, like most data stuff, is kind of the next step after you kind of figured out how to run them. And then there's another one called OpenLLM. Once OLAM has been very stable for me. As long as it doesn't require. Let's fire it up here. This is still running. Okay, I'll stop this. So basically, this is basically like a top for your NVIDIA card. So list. So PHI is that Microsoft model. And you'll see the GPU is starting to load here, only 190 megs, so not very much. And this is taking a lot longer to load than I thought. But then you can look inside the logs here, and then you can use that to kind of compare, learn about all the parameters, and you'll see this is, Llama CPP, and all of this stuff here. But now I can ask, what is LLMOps? And it doesn't know. What is DevOps? Okay, there we got it. So, and you'll see the memory increase and then different sized models. Right. I know we're probably running out of time, right? But anyway, you get the point here. This is 5 gigs. What is LLMOps? It doesn't know. I think there may be out of confusion. So anyway, OpenLLM is a whole other completely Python-based framework that you can use. Pretty complex. It installs like 15, 20, 30, 50 different Python libraries when you install it with Poetry. And I found that it does require a lot more GPUs because it's using pure Python and not the Llama CPP. And then if you're in an AWS or Azure environment, kind of learning the tools, and I haven't done this yet. This is on my list to kind of figure out the actual Terraform providers so I can stand this stuff up. So bottom line, this is kind of the kind of steps that I think you can learn this even if you're not a data scientist. I'm an English major. I don't understand vector math the way my daughter does, who's a comp sci. But you can figure this out. You can get useful information, use it for your own tasks, and then start to kind of observe the prompts, look at the performance, look at metrics. There's not much yet with LLM observability. There are a few tools that are starting to allow you to do sort of like LLM telemetry. That's a whole space that's also very early. So anyway, I'll put the links in the chat again, and I'll put these online. So questions, and there's been a lot of good questions. Well, Judy, I guess, are we done?
And we're off.